reserved. That's the didactic lecture, even though it's so boring. So here's the thing. Up to now, like the stuff that you did on the board, this stuff is what we call descriptive statistics. You didn't predict anything. You're just describing that data. So when you calculate the mean, it gives you a kind of with one number what a whole bunch of data looks like. So if I told you the mean of a test from 0 to 100 was 30, you already have some picture in your head. Folks didn't do so well. Something's in your head. So there's one number that tells you something about that data. If I tell you what the standard deviation was 20, then that also means that some people did better than others, a lot better or a lot worse. So you have some spread of the data. All right, so now we're going to go into what's called predictive analytics. So we're going to predict. And people think this is all I do is I predict, but sometimes that's not all we do. And it's what you think it should do. It predicts something. K nearest neighbors is a method. It's a method of prediction. In statistics, you probably learned about regression. In calculus, you do differential equations. If you were in JEDI, you were doing differential equations to predict. So we are very interested in predicting things. So K nearest neighbors is an algorithm. It's a machine learning algorithm. So you might hear about machine learning algorithms. It falls under AI. And it's really, really cool that you get to learn something like this in a freshman level class. I think it rocks. So with that said, I'm going to give you what's called a toy problem. A toy problem is not a real problem. It's just made up stuff so that you can get an idea of what this is. And I'm going to go through it step by step. So I'm going to do something called classification prediction. And I looked at your project and everything you do in the project's classification. Yes, no. Ranger tab, not Ranger tab. Easy, hard, I don't remember, but all 6 prompts have something with a binary outcome. So I made up data with the help of ChatGPT. So this stuff here is called my training data. That's how for machine learning, it's like the human mind. It learns from data and then uses that algorithm to make a prediction. So that's what we're going to do. So this is my training data right here. There's 8 households. This is the year salary in thousands. So 35,000 for this first household, 120,000 for this last household. This column here is the number of hours they work per week. It's made up. I don't know who's working 3 hours a week, but those people that make 120,000 are working 3 hours per week. I made it up. Not really like that big of a deal. And there's a new household, and this class here is whether they bought a product that I was selling. So these people up here did not buy the product, and these people down here did buy the product. Get it? Very simple. And my goal is to predict household 9, which I misspelled. Will they buy my product? So, step 1. Do take notes. We're going to do this step by step. Step 1 is to compute the means and the standard deviations. Sometimes they refer to that with a little s, sample standard deviation, for training data. Will we have training data every time? You have to. You know, it's very much like I gave an example to my consortium. It's like a little kid who's sitting at home and they learn who should they not be afraid of. And people come to the house And they get this like bigger and bigger picture of these people I don't need to be afraid of. And they learn from that. Now, if a new person comes, like a family member of somebody who visits the house a lot, you can now predict that they're not going to cry when they see that new person because it's part of the same group. They've trained on some data.
How would you make the training data?
Usually we have to have big training data sets. That's why.
For the product, are they given to you?
Yes, they have to be given to you. You're asking a very important question. How much is enough? To really learn something with machine learning, you need to have lots of data usually. Our rule of thumb is at least 1,000 observations. We're not going to do that here because this is a toy example. All right, so I'm going to skip this, but I called this data here, income 1, I called this X1, and I called this X2, so I don't have to write hours and all that stuff at each time. So the mean, X1 mean, turned out to be, I just used Excel because I'm lazy. I know this can do it. So I just went and highlighted, I just went to descriptive statistics, went up here to data, went to data analysis, and I crunched out this thing right here all at once. That's why I did it that's why I taught you that, so that now all you have to do is push it, and then you can get this one sheet. And so I get the mean is, as you have on the board, 75, and the standard deviation for X1 is, let me see, you guys have it on the board, 31.62. 78. You can put the whole thing down. And for X2, the mean was 6.625, and the standard deviation was 2.66927. So that's step 1. Step 2 is to standardize the variables. And the reason you do that is in machine learning, we always do this in machine learning. If you don't standardize variables, one of them will overpower the other ones. Let's say I wanted to predict, and I have done this actually, I wanted to predict who does best on the max deadlift. And I looked at all these body measurements. I have these devices downstairs. If you come to my office, it's a really cool office. I have these scanners where you stand on a Lazy Susan, and in 45 seconds, it does body taping all over your body. So you can get bicep circumference, forearm circumference, waist circumference, all of it. Height, weight even, because the thing on it has a scale on it. So it gives you all that data all at once. The problem with that is that the bicep circumference is small in comparison to height and weight. And so the height and weight will overpower those other variables. So you put them on the same playing field and you standardize them. And I showed you how to do that on using standardize. I didn't do it that way. I forgot about that. But I want you to do up to boards 1 by hand. Let me go to the next page. So the variables that I put up here as inputs were fake, household income and hours worked per week, but these are things I think that are going to be predictors. And so I punched them into Excel and did it, but you can do them by hand. So let's do one by hand. The formula for a z-score is this. Thank you. I'm happily writing. I'm having a math party by myself, which is usually the case. So I just crunched through the first number. And I did z is equal to 35 minus 75 divided by 31.6228. And I got minus 1.265. use the first number for the hours worked. Standardize that one as well. So take board. Huh? Yeah, you can erase that. I'll paste this up here so you can see it.